Through the circuit we taught just now, we have talked about the power OK and power good inside the Southbridge, or it's all power good, the circuit of these two signals. They are working before a clock. We know our Southbridge PCH. Although our notebook series are all bridge and CPU together, but working together or split open to the work of this point does not have any objection to. Then we receive a few power OK in this PCH. PM16 power OK, here I only write 2. They are servo specific. You can go to chat drawing to see how many power OK it has. After we receive power OK, our crystal oscillator started to start. What does it produce? Some are 25 MHz, some are 24 MHz. It generates this crystal oscillator as clock module. It only generates a reference clock. It has a negotiated capacitor and generates a reference clock. Actually, there is a driver inside our bridge. This reference clock is generated first, and then there is a frequency driver in it. Because the frequency required by each device on our laptop is different. Then after the frequency driver, the frequency is up or down to each device. It sends out virus clocks to our device. We're just the internal clock controller. It also writes the word CLK, clock. In other words, after the crystal oscillator works, the Southbridge internal clock driver outputs clock signal to each module. Like our network card, I/O, hard disk, including CPU itself, it needs a clock to distribute. I only drew 4 lines here, but their principles are the same. If this clock is damaged, it will also cause our laptop no boot. Can be triggered by the screen no light. That means the clock is damaged. The same PG damage will also cause our unlight screen. It's just that the probability of PG damage is greater than the clock. Before we check the clock, we must first see if the PG is normal. This is something we should pay attention to. So when do we check the PG clock during maintenance? It's very important here. So when do you check the PG here? This PG and clock include all power good and power OK inside our Southbridge. You have to check it. As mentioned earlier, check the PG first, then check the clock. So what is a fault if it cause? That is to say, it can trigger but screen no light. The current is fixed at about 0.4 ampere and 0.5 ampere, and it has reached the parameter. Current connected to the power supply. Its current set at about 0.4 ampere and it won't move. Like this time, generally we first check the above 2 PG lines. PG is normal, then check the clock. Some of the clocks are 24 MHz and some of them are 25 MHz, depending on the model of the laptop bridge. If these are normal and the clock circuit is normal, if the measured clock oscillator is normal, but the clock still doesn't come out, so what does it mean? Replace the bridge. there is no need to flash the BIOS. It also causes the clock to abnormal, either the PG is broken and the crystal oscillator is broken. The crystal oscillator of the Southbridge or the Southbridge itself is broken. There are 3 reasons why he has no clock, most of which are PG, so pay attention to. The probability of the crystal oscillator breaking is not high, either the bridge or PG. No clock caused by this circuit. This is a general flow of this clock circuit. During maintenance, since we haven't reset yet, even after clock is normal, about 0.4 ampere, there is a BIOS at the back, and it is reset at the end. If these are normal, and here is tended to talk about. Because we haven't talked about the reset yet, I will explain it to you again. If it doesn't move around 0.4 ampere, that is to say from PG, clock, bridge, BIOS, reset. Either the CPU itself has a problem or the CPU is broken. That's all that caused this situation. These circuits are being repaired. This is the idea to repair them. We haven't talked about the reset circuit and BIOS yet. Let's figure out the clock first. So how does the clock measure? Very simple. We can find the key test points of the clock to test through the circuit diagram point map. The voltages differ in different devices. Try to use an oscilloscope to measure. It may be more accurate. If you use a multimeter without an oscilloscope, there is basically no problem as long as there is a voltage. This is the explanation of the clock and PG. We have finished talking about the clock and PG, then let's talk about the reset. Reset is also called clear initialization. All laptop resets are generated by the Southbridge. It is produced by the Southbridge, the PCH produce. When did it be generated? After receiving power OK. After receiving the 24 MHz crystal oscillator. The internal clock module also works. Then the third step is to match the BIOS program. In fact, there is still a part of work behind the clock. Then it generates PCH, resetting the Southbridge inside, marked English called RST PLT. We also call this signal platform reset. It is normally 3.3 volt. The number sign represents an instantaneous low level. After it is turned on, it changes from high to low and then from low to high. Its real process is 3.3 volt. The process of changing from 3.3 volt to 0 volt and then to 3.3 volt after pressing the switch. In fact, in actual maintenance, we only test that it has the 3.3 volt is basically okay. This 3.3 volt can only be measured by a high precision multimeter. Or an analog multimeter can test this jump. Our digital multimeter is not so obvious, so we only need to understand this point during maintenance. But in the actual maintenance, if you don't have an oscillator or a pointer multimeter, we use a digital multimeter to test that has 3.3 volt is okay. Then the reset circuit is broken by the Southbridge. Since the Southbridge cannot generate reset, it is nothing more than the PCH cannot generate reset. Nothing more than just a few reasons. Either the PG is not normal or the crystal oscillator is not normal. This probability is low, or the BIOS is abnormal. We need to flash this. We'll talk about the BIOS refresh in the next class. Fourth, either the bridge is broken and the reset is abnormal. That is, if the reset is normal, connect the power and press the switch. See if its reset pin has a working voltage of 3.3 volt. If there is, it means that the reset is okay. If not, then there is a problem with the reset. To check whether these are normal, check the damaged components a little bit, according to the routine. Repair the circuit diagram bit by bit. There is our approximate reset. Next, let's take a look at how to find the reset circuit in the Southbridge. Let's take a look and find the reset in our Southbridge through the circuit diagram. This is reset inside the Southbridge. Immediately after the clock is working, take a look at the F7 pin of our Southbridge. It will send out a 3.3 reset signal. Look at the direction of this arrow. If this pin does not output the 3.3 volt, it means the Southbridge has been closed. Where did it go? Let's take a look at this circuit diagram. This is out of the entire Southbridge. Let's look at this reset position. After passing through this resistor, it changes the end of the name. Go to a different location behind. Go to each device on the laptop. In other words, this resistor must not be broken during maintenance. Resistor line R27A1. Not reset is not necessary by Southbridge. It is possible that one of the resistors has dropped and burned out and water has entered. After this resistance, it changes its name, but the voltage is still 3.3 volt. If there is 3.3 volt on the end of the resistor, there is no 3.3 volt on the other end. That means the resistor is broken, but it can be shorted. Which one of our devices reset to, and then specifically search for each device according to the English. The total reset is generated by the Southbridge. If there is no 3.3 here, the Southbridge may be broken. But before resetting, you will still have to flash the BIOS to prevent the BIOS from causing no reset. We still have a lot of Apple laptops, like Windows without reset. Generally speaking, we don't flash the BIOS. Apple needs to flash the BIOS. If the BIOS still doesn't work, we need to change our PCH this time. Side of PCH over, which is our Unity bridge. It passes 3.3 volt and sends it to various devices of our notebook through these resistors. During maintenance, what equipment should you pay attention to? For example, our first line is to EC, as MC stands for EC. SD card slot, every device in it needs to be reset. As long as one reset is abnormal, its corresponding device cannot work. Conversely, if the total reset is not available, then even the machine cannot be turned on. Like this total reset PLT RST. How to find our reset circuit on the circuit diagram? First, find the Southbridge is the first. Find the reset signal pin inside the Southbridge. Follow the English search to find the components on the corresponding circuit and check them one by one. This is how to repair the reset circuit. The probability of damage to reset circuit is not so great as the power supply. Relatively speaking, it has a low probability of damage. I'm afraid that it will be immersed in the water or severely drop, which caused the reset to fall, so that our notebook cannot light out in this case. This is the repair method and procedure of the reset circuit.